I'm in Germany, so I'm trying to start on time. Respect the culture. Hi everyone. My name is Fabrice Bernhard, and I'm really happy to be here again. This time to talk about the DevOps wonder. So just a small introduction before I start. I'm the CTO of 2 companies in France, and one of them is Iterate.com. It's the website for sports bars showing games in France. So, quick example, you really want to see the next Hertha Berlin game while you're in Paris, you can go on the website and find all the bars and restaurants that will actually broadcast the game, so you'll be able to follow it. So this is my experience as the CTO of an internet editor, and the second company is Theodore. It's an IT consulting company based in Paris, specialized in Symfony development and Agile development. We're now over 40, and of course it's much more dev-focused. So these 2 experiences, one which is more ops-oriented, one which is more dev-oriented, really made me take interest in the DevOps movement really early on. And it started around 2009, and it's really strong and growing, and I'm really happy to present that to you all today. So I decided to call the presentation DevOps Wonder, and I clicked on it this morning that I was actually doing the presentation in the church. I think it's a funny coincidence. So yes, brothers and sisters, I'm happy to talk to you about the DevOps Wonder. I hope I will make you believe in DevOps at the end of this talk, and show you the lights towards fast IT. So the way I will introduce the subject is first, it's something I'm often talking about, but I think it's really so important in IT that I will go quickly through it again, which is why are we actually interested in speed? In general, what is so important about speed in IT? Then I will of course present how DevOps is really solving the speed problem, and not only claim it, but bring you 2 things: numbers, because studies have been done on DevOps efficiency, and use cases, really amazing use cases, which you can use to convince yourself or convince your clients that DevOps is really something good. And then I will share with you the way we introduce DevOps and try to bring the dev team to a much more DevOps state of mind. It's a step-by-step process, which is quite pragmatic, so of course I will. Your feedback will be welcome. So let's start with the need for speed in IT, something I've already done, I think, actually last year in a different context. But yeah, the basic need is always the same. We're today in a digital economy, which means that we need to, if you want to succeed, you really need to go fast. It's not the big that need the small anymore, it's the fast that need the slow. And you can see that in really different contexts. You can see how traditional old companies are struggling against internet startups. You can see how competing internet startups, usually the one winning is the one going the fastest. Not always all the time the best product, but the fastest one, because they are able to adapt to the needs much faster. You can see that in the open source. I don't know how much speed has to do with it, but it's true that we have, for example, in Symfony 2 admin bundles competing, and strangely enough, the one that is leading is also the one that was the first out. So speed is often like the way to take the leading position. And quickly through, it's not the most important in the talk, but the way IT project management has been done for years before the V cycle is something that is trying to reduce risks by putting a lot of steps in the IT project process. But of course, the direct consequence is a time consequence. It takes a lot of time to release features. And actually, even it has a pervert consequence, I would say, because this whole thing makes it really risky. When people are wondering what this claim comes from, I've got this really interesting study by 2 Oxford professors that has been done on almost 1,500 IT projects. And what they saw is that 1 project out of 6 costs on average 3 times more than expected. So that's 30% more, it's 3 times more, so it's really a catastrophe for the guy who paid the project. And in general, what they realized is that large-scale computer spendings were 20 times more likely to spiral out of control. This means that people were assessing risks and trying to measure risks, and the result was that basically 20 times more often than expected, things were going wrong. And with horrible consequences, my favorite one, not my favorite consequence, my favorite example is Fox-Mayer Drugs, which used to be the 4th largest pharmaceutical company in the States. So a huge company making billions, and they went bankrupt when they switched to, they switched to SAP, brutally had a lot of problems, and 1 year after went bankrupt. And of course, there's a study that tries to relate this bankruptcy to this IT project that failed. And the interesting idea behind that, what the Oxford study actually says, is that it's because the way evolution has made us assess risks. What we've been exposed to in nature for like hundreds of thousands of years is basically Gaussian outcomes. Usually when you see a lion, or a small lion or a big lion, the size probability looks like a Gaussian. So that's how we assess risks. And fortunately, when we look at complex systems like large IT projects, the risk is not Gaussian anymore because you've got self-feeding mechanisms. It looks more like this, and all of a sudden, what your brain naturally considered as a good case scenario and as a worst case scenario that was like not really probable becomes really probable, and even worse, the worst case scenario becomes much, much worse. And so the solution to that is quite simple, is to just cut the large system you're attacking into small pieces, and this is of course what agility will tell you, what lean startup more recently has been really advocating for. And the smaller the pieces, of course, the less the system is complex, the less risk you're taking, the quicker you can actually correct things if things fail. Now, the really interesting thing I want also to tell you is that if you take Scrum, Agile development, okay, they're advocating for small iterations, but these are fake iterations. This is like, for example, the typical kind of graph you find on the internet. Why am I saying it's fake iterations? Well, everything is in the word here. I hope you can read it. Potentially. When you're doing Agile development and you're doing it only in the development team, what you're doing is you're thinking you're going fast, but the business value you're creating can be 0. Typically, that's what you will see in large organizations, where you have this like giant silos with like a development department and an operations department, and the way they communicate is like through top management because they're so different. And I've seen that in many organizations. It's really something that is common. You can even see that in small startups when they start growing. That's the way they usually organize themselves. They put the dev team in a place and the ops team in the other place. So even if you do like really amazing Scrum and the dev team, and I've seen that done in large organizations, what you usually end up with is potentially shippable features that are piling up in front of the ops department. And usually, it piles up until management realizes there's something wrong happening. So that's really the limit of Scrum, if Scrum is only implemented in the development team. And that's what Devops is trying to solve. I'm not saying that Scrum is wrong. I love Scrum. I'm a big advocate of it. We're using it really rigorously at Tildo. But what I'm saying is that the Scrum prophets, they showed us light iteration, and they showed us the first steps to it. And if you read the Scrum Guide, you will realize it's a simple framework, and it's not contradictory at all with DevOps, and it should actually be. That's why you should try to find ways to extend it to operations. So that's when people realized that and start gathering around this idea that the word DevOps was coined, and this DevOps word is now a movement, is now the flagship of this wonder happening in really efficient IT organizations. So the whole point of DevOps is solving this silos problem, breaking the silos, and this is my attempt at making a definition of DevOps. So it's not a tool, it's not a process, it's trying to make the whole IT organization work as a unique team and with a common goal, which is business-oriented IT performance. So going fast but being stable. Well, every constraint all together, and the way to solve it is to solve it as a team, which is of course quite hard. So usually and it just happened to me, like people say, oh, you're talking about DevOps, or you're talking about Puppet. DevOps is often related to, Richard is laughing. I don't want to answer you. So when you think DevOps, you often think the tools that go with them, sometimes the processes. Of course, the DevOps people usually say it's not only that, it's three things. So the DevOps trinity. I'm so happy to be in the church. So the DevOps trinity is tools, of course. How will you be able to implement DevOps IDs? Processes, when and how we will implement these tools, and people, why will you do that? How will you manage to convince them to do it? And these are the three pillars which are all really important that enable you to have a DevOps state of mind in your organization. The people part is really important, and everybody says that. I'm sure everybody would spontaneously agree, but I wanted to illustrate it because I think it's every time I realize it's a people problem, it's always like a new discovery for me. So I tried to find what the role model for developers would be and what the role model for operations would be, like caricatures of the both worlds, and put them together on the same slide. So for the role model for developers, I chose DHH, the hipster developer, the creator of Ruby and Rails, the guy that wears yellow shoes. And in front of him, I'm inviting Stallman, the epitome of ops guy, because he's such a GNU Linux guru. If you say Linux in front of him, he's really unhappy. So GNU Linux guru, he's completely paranoid, he doesn't have a cell phone because it's dangerous. It sounds like the typical ops guy to me. And of course, when you try to make them talk together and make them work together on the same project, they're in direct contact with the business, so what I'm thinking about is speed and short term. So the typical thing you get is like, wow, I got all these new technologies together, CouchDB, Node.js is connected to S3. I promised the business it would be online today. Can you let me deploy it now? That's the typical dev. And of course the ops say, what are you talking to me about? New technologies, I haven't tested them, I haven't seen them in production, and the ops guy is thinking stability, he's thinking long term. It's also like business incentives, but he's more focused on long term ones. And he's scared, and he's of course mentioning all these really important issues, which are backups, monitoring, performances, security, scalability, documentation. When you're introducing new technologies, these are all the questions that the ops is thinking that the developer completely forgot because it was working in his machine. And of course, in the worst case, when people don't work as a team, you get neither short term nor long term. You get complete freeze, and business is completely unhappy. He's realizing business is not going to be happy. So that's what DevOps is fighting against. And the really interesting thing is that it's such an important thing. It's concerning so many organizations that studies have been led. Two recent ones. One led by Rebel Labs, which is a Java-oriented company. So they surveyed 620 engineers, and one led by Puppet Labs and IT Revolution Press together. And they surveyed 4,000 IT ops and devs. So really interesting study. And of course, if you want to see more examples of how it works, you can find testimonials from web leaders, Amazon, Netflix, Etsy, Flickr, everything. I'll give you some links at the end. A really interesting source of information is Velocity Conference. Devops Days also is quite interesting. So to give you facts that will really prove that DevOps is not just a buzzword or a miracle, but is really something that is, even if it's a buzzword, that is connected with real things that really bring efficiency in the organization. We'll first show you 4 results from the Puppet Lab study and 3 really interesting examples. So the first result, the Puppet Lab study is a bit complicated to read, so I try to make it easier to read, but to be honest, it's not much better. Anyway, so what they did is they surveyed 4,000 IT professionals and they asked them to say, so it's their own claim, if they were non-DevOps, or if they had been like DevOps for a short time, or if they had been DevOps for more than a year. So I took the 2 extremes, those who claimed they were not DevOps at all, and I took the other extreme, those who claimed themselves that they were DevOps for more than a year. And for example, right now we're looking at the frequency of deployments. How many times per day, per month people are deploying. And of course you see a huge difference between people who say we're not DevOps and people who say we've been DevOps for a year at least. Well, 27% of the people who claim they're DevOps are deploying on demand, which is like more often than once a day. And of course when you look on the other extreme at people who claim they're non-DevOps, some are deploying, 35% of them are deploying less than once a month, so that's a huge difference. On average, these 2 bars show you that people who claim to be DevOps ship in average 30 times more frequently. This is a huge number. So this is an average, you can see how it's distributed. Which is of course like a really interesting thing, because this is the measure that shows you how quickly you're iterating. Funnily enough, you can see that some people are claiming they're DevOps, but still need more than 3 months to deploy less than 4 times a year. So that's the limit of this study. Like people are claiming, you must have not understood everything about being DevOps. Of course, they're deploying more frequently because they're deploying more faster, much faster, 8,000 times faster in average. Once again, you can see the distribution. You've got 25% of the non-DevOps that need more than a month to deploy, which means that when they decide, okay, it's time to start deploying, they need a month to say, okay, we finished deploying. You can imagine the amazing process you have. You go to the security department, and then you go to the ops department, which doesn't have a server ready, whatever. So really complicated things that take months. While, of course, 23% of the DevOps teams are able to develop and deploy in less than an hour, which is easy when you're dealing with one server. It's of course much more complicated when you're dealing with thousands of servers, but some manage to achieve that nonetheless. You could think that deploying faster and more frequently would have like a clear drawback, which would be a stability. Well, for those of you who heard about DevOps, it's not a surprise. Of course, DevOps team actually fail less often, 50% times less often, according to the study. And of course, the main advantage they have, they restore service when there's a failure 12 times faster. So 50% of the DevOps, and this is a huge number, are able to solve the problems in units. So this might be, actually this bar shows that this might be the first focus of people trying to implement DevOps in their organization, is trying to reduce the mean time to resolution. Okay, so these were like really theoretical studies. Let's see what happens in the wild, and especially how far you can go in this quest for like a high frequency deployment. The leader, by far, the prophet, is Amazon. So Amazon, which was founded in 1994, is now doing $61 billion revenue, so of course a huge commercial success. Has an IT organization that is amazing, like is magnitude better than the second best. Their mean time between deployment is 11.6 seconds, which means that every 12 seconds, there's a guy deploying something on servers, on live servers, in the Amazon organization. 11.6 means that they're deploying more than 310 times an hour. This is completely, of course, they're the only ones to reach these kind of numbers. They're really proud of their record. It must have been like before Christmas, where they reached the one deploy every 3 seconds. I remember stating these numbers at the conference, and the guy told me, "Oh, you must have made a mistake because you said 12,000 times an hour. It must have been 1,000 times a day." No, it's 1,000 times an hour. Completely amazing. And you might think, well, this is what I thought. Okay, they're talking about deployments, but these are like small things. They're impacting I don't know. No. Every deployment, on average, is impacting 10,000 servers. It's completely ridiculous. Compared to the scale I guess most of us are dealing with. If you don't believe the numbers, which I would completely understand, you can check the presentation on which it's based on. It's the Velocity Culture keynote at the Velocity Conference in 2011, I think. I think since then, Amazon has been communicating really little about the numbers. I think it's because they realized they were so much more advanced than all the others that it was time to just hide everything and keep it secret. Okay, you might think, okay, Amazon, they're really good, but that's completely unreachable for us. So a much better example for smaller scale startups is Etsy. Etsy is really amazing. So they've been founded in 2005, a much younger startup, but they're already doing $1 billion transaction. That's what they are targeting for in 2013. They've got a huge team. A lot of people are able to commit on the source code, 250 people. I think that includes designers and content people. And a lot of people are actually touching the repository. And the rule is that everyone that touches the repository is able to deploy. And the way they actually introduce this culture at Etsy, which is really amazing, is that they have a rule: when you arrive at Etsy, you have to deploy in production the first day. And so what they do is basically Etsy, I don't know if you know, it's like how do you call that? A platform for artists and handcraft things. So people can sell many things on the platform. So of course they're really much into homemade things, and they have a homemade photo booth, and you have to go inside, take a picture of yourself, and then find a way to deploy it on production on the team page. So a really interesting idea to bring this deployment culture. With of course the result is that they deploy more than 30 times a day. They have more than 7,000 tests, I think, to ensure that nothing gets broken. And that's how. I mean, we don't know how much the IT excellency of Etsy is responsible for its business success, but it's sure that we're talking about a company that is not doing anything really innovative business-wise. They have a lot of competitors, but they're the ones who took the leadership position, and certainly because they were the fastest. And one other sign that would actually prove the correlation between IT excellency and the business success is the fact that the current CEO is actually the former CTO. So the shareholders decided that the CTO was fit to become the CEO of the company. So this really shows the focus on the IT excellency. Okay, one big startup, one small startup example. You might think, okay, this works with startups, with tech-savvy people, but I'm dealing with a large organization, traditional organization. That's never going to work. But certainly it's much harder. But I've got this amazing example for you. I'm in love with this example. So, gov.uk. So what is gov.uk? It's the websites of all government departments and many other agencies and public bodies. Just copy-pasted the definition on the website. So basically they decided that in the government, many people were handling websites in different places with different web agencies and web teams, and that wasn't possible anymore. So they just decided they would merge everything in one hugely efficient team. So of course they didn't start right away. They first did an alpha with 4 developers. In 3 months they showed they could do that. They were deploying multiple times a day. They were deploying on Amazon. Can you imagine? The English government deploying on American servers, hosted in Ireland. This is, if you've ever worked with like large organization and government bodies, you can imagine how radically different it was from what they usually do. Of course, now that the site is live, it's not on Irish servers anymore. But they, of course, they kept also the cloud platforms that they're using other cloud providers in place in England. So in 3 months, I think, 3 or 4 months, they were able to do the alpha, prove their points. The cabinet office said, right, let's go, continue. So they grew the team, and in less than a year, they had managed to merge and migrate all the websites of all the ministries of the government into this gov.uk website, which is highly responsive, and of course with like an amazing team, people recruited from internet backgrounds, not from government backgrounds, and still deploying multiple times a day. And it's really interesting because they had to sell themselves inside the whole government, because okay, they were sponsored by like one of the that's the good thing about politics, is if you're sponsored really high and things go fast. But still, you had to convince people all around you that you were actually doing things good. And what they claim is really interesting. They said our main selling point was that we were so much faster than what people were used to. People would say, "Oh, we'd like this feature. Can we talk about it in the next month, in the next meeting, whatever?" And 3 days afterwards, it was built, it was shipped. And that's how people said, "Okay, fine, we respect you." So this is a really interesting example. I really love it. It made me want to become English when I heard about it. Richard is English, so I'm really happy. If you don't think I'm serious, it's because you don't know me, because I've been dating an English girl since then. Yeah, I'm true to my principles. Anyway, so a really amazing example, and I really wish that France will actually adopt it, and Germany, of course, also. Okay, so now I hope I convinced you that DevOps is really something amazing, and that you have numbers to back it up, and or to convince people around you if they're not convinced. So now let's start addressing the issue, pragmatic issues. How do you start practicing DevOps? How do you introduce that in your team? Is it just about using Puppet, or is it a little more complicated? What people in the DevOps movement say is that there are 4 maturity levels of DevOps adoption. Since I was doing this talk in the church, I'm reduced the 4 levels to 3. I think trinity is better. So the first maturity level is when you manage to extend development into production. So when you bring devs closer to the constraints of operations. Then once you've managed that, of course, you're trying to bring operations to give more feedback to developers about how they're influencing things and try to empower them. And the third and fourth maturity levels is when you manage to actually further embed both teams, devs in the operations teams and ops in the development team. So I'm going to share with you the secret of Theodore. I don't know how valuable that is, but this is how we try to really introduce this culture in our team. So let's really start with the beginning. So if you really look at what a junior dev looks like, I mean really junior, the kind of guy that you hire at the end of university, that usually, well, he learned Java, because he did some computer science. He still uses Windows because it's cool for games. So when you start like grimacing while hearing that, he like reassures you, no, I of course installed Linux because I'm a curious guy. I mean, if he's not curious, you shouldn't hire him anyway. And since he's like coming for a web development position, usually his like passion for web comes from, or has been expressed by maintaining a website of one of his clubs at university. Now, of course, the interesting question is, okay, if you maintain a website, how did you push that on the server? How were you hosting the website? And usually the answer is, oh, it was quite simple. I was pushing files using FileZilla. So you know that you have a lot of work to do. But usually it doesn't mean that you should hire the person, because if the person is really passionate and really smart and has a strong background in programming and languages and analytical things, this can also become a really, really powerful DevOps later. So first things, make this baby dev a respectable developer. So this is, I guess, the things that everyone here knows really well. Use a Linux development environment, introduce Git, teach Git, teach like the correct Git branching strategy, depending on what you prefer. Try to make him, of course, this junior dev efficient in the way he organizes his development work. So what we use is like rigorous Scrum in our teams, and also introduce like concepts of code quality, test-driven development, unit testing, function testing. So you've got a developer that is now not a baby anymore, it's respectable, what I call a teenager developer. Usually he's already really proud of himself and starts doing conferences about unit testing. Then, of course, what is really interesting is I made a kind of quick survey in the company and was trying to understand why some people were much more proficient at system administration than others. What was actually the differentiating thing in their history. And it's always came to the same, like I host a web server, I have a web app, I have my own web server. It always came down to the guys who is actually administrating his own server. So the answer to that is, of course, we decided to give a tiny instance, server instance, to everyone, where they're free to do whatever they want, whenever they want, of course, as long as it's legal. And they might not use it right away, but if you have passionate developers, at one point they will have like their personal project or anything that they want to host themselves, and they will have this tiny instance that they can play with, that they can make mistakes with and learn about out of. Of course, we don't want to wait for developers to learn by themselves. So usually the first thing we do, if these people have really little server background, is to ask them to set up a simple server. And twice. So why twice? Because later on we want them to learn provisioning, and since tools like Puppet and Chef are not that cool, it's good to see what they're replacing. When you've been doing 2, 3, 4 times the job of configuring a server, you start understanding why it's important to use tools like Puppet. And to be really like pragmatic, what we do is like first we ask them to do a simple setup with Apache, and then wipe everything out, destroy the instance, start again with Nginx FPM. And usually people are really happy after that, because it's not they learn much, but they discover many problems, really funny things. For example, we use tiny instances, so you couldn't install Symfony 2 with PHP 5.3 because you didn't have enough RAM. Well, you're happy when the guy tells you, like, oh, I had to go to unplug and find out to like install a better version of PHP. You know that he's learned like the job the hard way. And then, okay, now you've got a guy, he's a good developer, and he's seen at least like 2 times how it works on a server. Doesn't mean he's like a good system administrator, but at least he's not afraid of it anymore. So the next step for me is to bring him to deploy automatically. And what I'm really interested about is also that he understands how it works behind the scenes. So shell scripting, this doesn't make automatic deployment easy to understand or easy to change, so I just forget it. And then the 2 competing solutions I see are mostly in like the Symfony, especially in the Symfony world, are Capistrano and Fabrice. So we haven't decided yet, and at Theodore we're using both. I'm the big advocate for Fabrice because I think it's a good compromise. It works well and it's not magic. And I'm trying to see some feedback from junior devs to whom we tell, can you learn like how to deploy automatically? And when you're dealing with Capistrano, they have like this crunch bugs they don't understand. So what we do is every project, of course, has to have the deploy Pi script or the cap file, and everybody has to be able to deploy the project at all time. Of course, what I see is that juniors tend to not deploy when somebody experienced is not around, but at least they know how to deploy, and it's rather a good thing that they're a bit scared to do it anyway. Just a quick example of why Fabric is so nice. The concepts behind are really simple. You've got a local function where you can wrap whatever shell command you want to execute locally on your machine, and you've got a run function where you can wrap anything that you want to execute on the server, remote server. And what we use, and this is certainly one of the good solutions, we use Git as the common repository between the local and the remote machine to communicate. And we use tags, which I think is a good practice, to say, okay, this was just put into production at that time. So you can know at all time when you look at your Git repository, this is the version that is online, etc. Okay, so the next thing, which wasn't that intuitive, but was like a real statement, was, okay, monitoring is so important, and developers never know how to do monitoring, they never think about it. So a junior dev, he's still a virgin, now it's time like to brainwash him a little, and make him believe that monitoring is easy and an obvious step. Well, the fact is that monitoring has become really easy today with things like New Relic and App Dynamics. I know that Dustin is representing App Dynamics today, so if you want to ask him questions, he's around. So it's basically you just do a few commands on your server and up it's connected to a really nice and web interface that tells you so many things so easily. You got really easy access to performance issues, hidden 500 errors, and I can't tell you how many performance issues that I wasn't looking at because the page was loading correctly. But when you realize it's loading in a second and a half, okay, it's fine. But when you realize it could be loading in 300 milliseconds if you just remove this small widget in the lower right corner, then you realize this really brings a lot of value. Or if, of course, you have like 500 errors on your production server and that you're not really it's much easier to like see them, debug them directly in these kind of tools. So yeah, by making it the step 4, we make it obvious that it's the right way to debug things in production and people are really happy. Okay, step 5 is to make, of course, continuous integration a logical thing in the process of deploying and to make it a responsibility of developers. So I've seen too often teams where the ops were responsible for maintaining the Jenkins. I think it's really bad because when the ops are not there, everybody is like not testing anything anymore, and it's so easy to set up a Jenkins. I mean, it's not so easy, but it's quite easy that all devs should be expert at doing it. Common things you will see, of course, is when developers are responsible for the Jenkins, you get conflicts between jobs, and then nobody knows who's responsible for solving them. So one solution is to use separate slaves for each project you're hosting on the Jenkins. This is actually really not that hard. It should look like the link I put, distributed builds. And if you have like a cloud, then you can connect one small instance to every one of your jobs. Or you can even actually connect your whatever pre-production instance. That is even better because then the tests are run on the same environment as your pre-production server. What we had in big projects where there were multiple teams and they were breaking each other's Jenkins, we had like a rolling responsibility between teams. Every week, every sprint, one new team was responsible for maintaining Jenkins. There are really interesting SaaS solutions which would be really like Trade CI, which is based in Berlin, which are really interesting when you want to do easy and quick to configure continuous integration. They're really good solutions. There my need is to make people proficient in continuous integration, so it's more for pedagogical reasons that we're using Jenkins. And also because it's much more complete. I mean, you can do whatever you want with Jenkins. For the moment, Trade CI likes like really important things like just grabs. Use grabs are important. If you look for Jenkins, and this is just because well, I was looking for the Jenkins logo and I found that. So it's just to say this is not the Jenkins we're talking about. This is somebody else. Don't want to leave any misunderstanding. So step 6, people were maybe expecting that. How do you normalize environments? This is really important because usually between the development environment and the production environment you have like really subtle differences. And I've seen amazing bugs, like we were developing in 64 bits, the production for server was in 32 bits, and a library we were using was not working on 64 bits, so you've been like struggling to correct the bug for a week on your development environment while it's working perfectly on the production environment. Of course, sometimes it's vice versa. So it's really good to have like the same environment, so the same architecture, same OS flavor in your development environment and in your production environment. This is what Vagrant brings. So it's a wrapper around VirtualBox virtual machines, and it enables you to really quickly set up the same kind of virtual machines on every developer's machine. There's a bonus to that called Vagrant package. We have got a new developer coming in the team. We haven't talked about Puppet yet. So you have a new developer coming in the team, you can take your box, package it, it makes like a 800 megabytes file, and you can ship it to the new developer, and you can launch it and start in a few minutes working on the project. A lot of people are complaining about Vagrant for performance reasons. It is of course less performant than working on your own computer, but there are some important performance tips that you should try before criticizing it, and they are summed up in Benjamin blog, so really interesting read. I haven't, maybe I should have made a whole slide about this blog post because it's really amazing. So simple ideas. The main slow thing about VirtualBox is the file sharing system. So if you change a little Symfony so that the caching and logging doesn't happen in the shared file system, then you get like amazing performance improvements. Okay, so now let's say we've reached maturity 1 level, which means that development has been extended to production. Now it's time for ops to collaborate and go towards developers and empower them, and start the love affair between them. So the next step. So finally, we've reached the point for Puppet and Chef. So we've reached a point where we want to easily replicate the same server configuration in development, in pre-production, in production, in testing, everywhere. And you have tools to do that, and the two main competing tools are Puppet and Chef. And to be honest, they're both really painful to use on a daily basis as a developer. So that's why it's very important to show that manual provisioning is also really painful at first. Or you will never be able to convince anybody to use them. The way we do it, because to be honest, that's the way it should work, is we asked our really experienced ops to create the template, the first template. And then you realize, wow, there's so much experience inside. You see so many subtle optimizations that as a developer you would never think about. All his 20 years of experience administering systems summed up in a few Puppet lines, and you're really happy to have them. Unfortunately, the drawback of that is that my first Puppet file was 1 file and 20 lines, and the first Puppet template that this ops guy gave me was 25 modules and 200 files for approximately the same kind of problems. The guy was coming and had just become like one of the best experts in Puppet because he had done like the whole infrastructure, the French Post, 80 servers, etc., etc. But that's when the developer is really responsible for challenging the ideas behind and simplifying things. Things that are valid for 80 servers are not valid for 1 full server. So you really need to simplify them, because if you don't, developers will never start digging into the Puppet templates. Of course, a really good thing about these templates is they're natively compatible with your Vagrant. So once you just do Vagrant up, and the same configuration that is used in production is used on your development environment. Okay, next step. Well, now we have common environment, ops and devs collaborating. Now it's time for ops to start hurting themselves a little and enabling self-service. So basically, this is what cloud is all about, is enabling developers to start things, to do like ops things without having to ask permission all the time. You've got public clouds like Amazon, then you have private clouds, and OpenStack is our mature enough. But we're using it in production. It works. It has a few bugs, but not in the more in the way you create your instances, not in the way instances run. So it's good enough. And that's really great. That's how we can, give a tiny instance to every developer. That's how we can create an instance for every job on Jenkins. I mean, you have your own cloud. It's great. And it's on Amazon, so it's a bit cheaper, which is also quite important. Something I haven't mentioned yet, which is backupping. Backupping is really important. It has to be easy. The two ways we do that, the ops has to empower developers to back up easily. We have Swift, which is the S3 equivalent of OpenStack, so you just have to push your backup files on in Swift, and then you can trust your ops to replicate them enough so that it will never disappear. If you don't want to even think about what you're supposed to backup, there are really interesting solutions nowadays. We're personally using Iterate server backup, really performant agent running on the server. Every time there's a file change, it backs it up. So it's really efficient. And you've got a really nice web interface where you can say, oh, I just deleted this folder, please restore, and it gets restored. Quite nice. Performance is a really important thing, and in the DevOps world, and I need to go quicker. What we have is the ops created us an easy-to-access server, so basically a remote desktop with a Gmeter inside, and the server has a huge bandwidth, so we're able to completely flood all our projects with load testing scenarios. Of course, we asked the ops to first teach us what he really was testing usually, what were the important things. And when the project is much about load testing, what we do is we plan to have regular load testing with the devs and the ops together. I'm waiting for the picture to be taken. Perfect. The slides will be online. Step 11, enforce pair devopsing. Because you still have a lot of issues, like dev team has an issue with Puppet Chef, they want to solve it on their own and they're like wasting time. Load tests indicate some performance issues, how are you going to solve them? Ops sees cryptic errors in the logs, doesn't know where it comes from. Well, the solution to that is just put a dev and ops together on the same computer. And I'm really happy I found an ops-looking Jesus and a dev-looking grandma to illustrate this point. So, yeah, pair programming, but with an ops and a dev. It's Scrum compatible. That's a really important point because Scrum says the technical expertise should be inside the team so that they can solve their own problems alone. It doesn't mean that they have to learn on their own. It means that they have to be coached and see the results and see the solutions so that they can replicate them or at least measure the consequences of these solutions. And so this pair devopsing is exactly the way to make ops expertise Scrum compatible. It works with curious people. If people are not curious, it doesn't work. Okay, conclusion, just hire curious people. They're better. And step 12, that's the end of this 12-step process for the moment. Use visual management a lot. Everybody will tell you that. This is really the easiest way to make a team focus on the same goals, even if they don't have the same local incentives. For example, performance. Devs rarely think about performances. How do you handle that? You put it in done definition of your Scrum done definition, so devs know they have to be performant if they want the feature to be accepted. Of course, you include performance solutions in the standard provisioning, in the development environment. If you want to cache things with Varnish, then you need to have a Varnish in development. And that's where visual management comes in. Just put visible performance graphs on your Scrum board, and everybody will naturally be focused on trying to keep the curve below the red line, and that's going to work. It's quite amazing how people are, really reacting to just a curve in a red line and trying to make it work. So it's easy management. Something I've been asking myself after these ideas that we were trying to implement. How do you bring devs to feel responsible for production as much as ops? This is a really nice XKCD comic, for those who can read it in the front line. Basically, it's Die Hard. The chief hostage is called by chief terrorist is called by another terrorist. There's a guy going through the vents, treading on broken glass and killing everybody, and the guy's like, what is he doing? He's trying to reconnect cables and muttering something about uptime. And then chief terrorist is really scared because he knows he has to deal with a NOPS guy, with a sysadmin. Of course, devs usually don't risk their lives for uptime, they don't care about that. So when I asked them, my developers in our team, why, they said, because it's not my job. I never signed for being woken up in the middle of the night. So I've seen lots of startups implement that, ask the devs to be woken up in the middle of the night. It's up to the business to decide if it's worth it, because it has, of course, a cost, money or psychological, whatever. And really quickly, the last slide. The next steps, if you want to learn more, for some reason, I don't know why, but all these companies, I know why actually, all these companies are communicating a lot about how they do it and how good they do it. They want to recruit people, but it's of course a really interesting source of information if you want yourself to inspire yourself from them. Riskier is one. You've got Etsy's blog, which is great. Netflix's blog is also amazing. Jin Kim has like 11 top points you should know. And if you want to do that, be it Lean, Scrum, Devops, it's all about continuous improvement. So measure everything. If you see a problem in your measurements, identify it, try countermeasures, and iterate. That's how you will reach Holy Grail. I hope that now you believe in the DevOps wonder. This is Prophet Bernhard, CTO at Amazon. He's the guy who's able to deploy 300 times an hour. We should just like all, respect him for that. And if you have any questions, I'm a bit late. Now it's time. Thank you very much.